If the 3 amp source supplies 12 watts, determine Vs and the power of the 10 volt source. Okay, in this problem, because we're solving for this voltage source right here, its value, well, that's a voltage, and we solve voltages by using KVL. Any path that we use to solve for Vs will include this 3 ohm resistor. Because KVL involves voltages, a voltage is equal to I times R. So our new mission becomes to basically solve for the current through this 3 ohm resistor, IS. And with that, then we can solve for Vs. Okay, so one of the first hints in this problem is that it tells you that the 3 amp source supplies 12 watts. So P is equal to VI. Well, we know P, and we know I because it's a 3 amp current source. So V is going to be P over I. And now they say that this thing supplies 12 watts. So our P, our power, is going to be negative. If they had said absorb 12 watts, we would use positive 12. So negative 12 because they say supplies 12 watts over 3 amps, or just negative 4 volts. Of course, now that voltage, that coincides with passive sign convention because that's what power deals with, passive sign convention. So current is entering the positive terminal, because first of all it's going from left to right because of the current source. So then the current must enter the positive terminal, so plus minus, with a value of negative 4 volts. Now that 3 amps is also running through a 4 ohm resistor. Again, following passive sign convention, so plus minus. 4 times 3 is just 12 volts. Again, that's just using Ohm's law. Alright, so now we can use KVL to solve for the voltage across this 4 ohms. And you should get 8 volts. So just going just like this. Minus plus 8 volts. So then you get that. Okay, great, awesome. So again, you would find that voltage by doing KVL in this host path right here. So that should be 8 volts. Awesome. Well, we have 8 volts over 4 ohms. So if we use Ohm's law again, I is going to be V over R, or 8 over 4, or just 2 amps. Great, awesome. So we have those two known currents. And if we found the current going down through this branch, then we could use KCL to find IS. Well, if we look at this KVL path right here, we'll find that the voltage across the 6 ohms is going to be 18 volts. Again, if you want to write out the KVL equation on your own, that's totally fine. Okay, so this current down here is going to be 18 over 6, or just 3 amps. Alright, so now we can do KCL at this node, at this one node right here, to solve for IS. So KCL. Current entering the node is equal to the current that's leaving the node. Okay, so what's entering the node? Only IS. I'll do red again because I said that earlier. So IS, let me do this, is equal to what's leaving this node. So just 3 amps, 2 amps, and a second 3 amps, or just 8 amps. So IS is going to be 8 amps. Alright. So now if we do KVL in this little loop right here, there's multiple loops that we could use to solve this, but this is the shortest loop. Okay? So we do KVL. Let's see, so we're going to do VS. Okay, let's go back to this part of the circuit for a second. So again, the current's going from left to right through the 3 ohms. So following passive sign convention, plus, minus. Okay, anyway, VS minus 3 times IS minus 18 is equal to 0. Of course, IS is just 8, so 3 times 8 minus 18 is equal to 0. So therefore, VS is going to be 18 plus 24, or just 42. So now we want to find the power of the 10-volt source. So because P is equal to V times I, well, it's a 10-volt source, so V is 10. So all we need to know now is the current through the 10-volt source. Well, so if we look at the 5 ohms right here, if we look at the nodes again, so again, if we look at our nodes here, the 5 ohms is in parallel with the 10-volt source. So because things in parallel have the same voltage across them, then the 5 volts has 10 volts across it. So we do plus minus 10 volts. Okay, so using Ohm's law, 10 over 5 is going to be 2 amps going downwards. Again, the current's going down because the current enters the positive terminal. Okay, so now we can do KCL at the top right-hand node, so right in this node. Also, we need to label the current through the 10-volt source. Again, the current has to go down into the positive terminal. We'll call this IX. Okay, so doing KCL. N is equal to out. Okay, so what's entering this node? We have the 3 amp current source pushing current into the node, and we have the 2 amps from the 4 ohms. So we have 3 amps plus 2 amps is equal to 2 amps plus IX. Therefore, IX is going to be equal to 3 amps. So the power of the 10-volt source is going to be 3 amps times 10 volts, or 30 watts. So because our answer for power is positive, means that we are absorbing 30 watts. You could also say supplying negative 30 watts, but that's kind of pointless. Alright, so that is it. I'll see you later.